everyone, and welcome to this Generative Design in Revit webinar. My name is Juliana, and I work in marketing here at MicroCAD. And today's presenter is Sandra, our applications specialist. At today's webinar, we'll see how with generative design you can explore multiple design options at once and make smarter decisions faster than ever. As usual, throughout the webinar, you can ask a question at any given point on the left-hand corner. You can ask Sandra to revisit a step or ask any questions. And in the upper right-hand corner, you will find links to our social media like LinkedIn. You can follow us there so you can be informed about our news, promotions, and events. And we have our YouTube channel and website. We also post all of our webinars on our YouTube channel at the end so you can share with colleagues or rewatch it on your own time. And we will be also sending the on-demand recording of this webinar tomorrow at 1 p.m. So you will have that as well. And without further ado, I'll pass it on to Sandra. Please, Sandra.
Hi, everybody. Hi, Juliana. Thank you for this really great introduction. Let me start by sharing my screen. And then let me introduce myself. My name is Sandra Wohlgemuth. Today we are going to be talking about generative design in Revit. Basically, I want to take you around through what generative design is, what it does in Revit. I'm going to show you a couple of the pre-written scripts that we have in Revit. Obviously, if you want to create other scripts, that is also a possibility. You just need to have a person that knows how to do programming in your company. About myself, I mean, if you don't know me yet, I am my name is Sandra Wohlgemuth, and I am an application specialist with MicroCAD. I have been a Revit expert for a bunch of years. I have been working with Revit since 2005. So very much like the software a lot, and I really like this beginning of using computational aids to help in your design, something like generative design. That is what it is. I'm going to try to take you through a fairly dry part of this presentation, just talking about what generative design is. And at the end, I would like to show you two examples of how it works and what it actually does. So let's get going. First of all, and I'm going to start my presentation with a question. Basically, what is generative design in Revit versus the Dynamo player? And the big difference between them is that both of them, let's start with where they're similar. Both of them, they allow you to run Dynamo graphs or scripts from Revit, and they allow you to interact in the model in a certain way. Both tools are designed to allow Revit architects and engineers who may or may not want to be proficient with Dynamo to run a graph without that much of an issue. As I said, the graph needs to have been written by somebody. The Dynamo player is going to be used to perform some functions in the current model. Some of these graphs can calculate room occupancy, loads, update sheet names. I mean, I used to run a Dynamo, through the Dynamo player, I used to run a Dynamo script to clean my architectural models to be able to use them in the MEP industry. So there is a ton of use in Dynamo. Generative design, from my point of view, goes a little bit further in the sense that it allows you to generate multiple possible solutions to a design challenge. So it allows you to examine and evaluate alternatives and choose optimal solutions. And then you can integrate those solutions into your model. So as I said, if you're not proficient with Dynamo, you will need to have a Dynamo author. But I mean, I am not a programmer, and I can tell you with my absolutely non-programming skills, way back in the day when Dynamo first started coming out, I was able to write Dynamo. Come with Revit out of the box. And with those as you're understanding Dynamo, and then a programmer can help you develop further scripts for generative design. So just to read, in generative in Revit, explore alternatives to a design project. So it can be a massing study, it can be the seating of a restaurant, which is one of the examples that I want to defining the best seating position according to a specific view. It can be placing trees within a public area outside of your building, and it will give you a whole bunch of different options. So it will give you many design alternatives that will help you define your most optimal solution. So to use generative design in Revit, you will need to find the tool in the Manage tab. There is a generative design panel. You will create a study, and then you can study the outcomes. I will show you the dialog boxes and the locations towards the end of my presentation, so that you get to see where in Revit you can find the tool itself. And then there are different study types. As I said, the study types that I'm going to show you are examples of generative design studies that you get when you install your Revit. And they are based on Dynamo scripts that address particular design problems. So we're going to talk about the first example is a way to create massing models, where you will have the possibility of defining varying heights and relative positions of 3 simple masses. And it will give you feedback in terms of areas, floor areas, and surfaces. There is a script to maximize window views, and there is a script to randomize object placements. You have 2 views in the generative design toolbar that opens. Either you can see them graphically, or you can see them as a list view. And also, I'm going to show you where to find them. So first of all, when you are creating a study using generative design, you need to choose the underlying logic for generating the design alternatives. So your design alternatives is going to be to optimize and to iterate to meet goals, or to randomize using random values within ranges, to space evenly, so it means it's going to evenly distribute values within ranges, or to, like this, explore variations of a preferred outcome. So to dwell deeper into those concepts, when we say that we're going to use the option to itemize, to optimize, to iterate to meet goals, it means that you can generate designs that are optimized for your goals, in generative design, we'll run multiple generations of a design. Each succeeding generation evolves and improves based on prior designs. When we use random values within ranges, we're going to use this method for optioneering to explore a wide sample of possible solutions that the study type can produce. This method is going to be helpful for exploring design alternatives quickly when you don't yet know what metrics you want to optimize for. So the variables that you're going to randomize, you're going to define specific ranges, and then you can specify the number of outcomes to create, or use the default value, which is a value of 40. And then generative design will generate outcomes based on constraints defined by the study type. When you define to space evenly, and evenly distribute values within ranges, you're going to experiment with different combination of variables using evenly spaced values to generate a specific number of outcomes. And we're going to explore that by exploring the seating in a restaurant, okay? How many tables I can place in a specific area. So when you are generating a generative design, you need to consider criteria that you will use to generate design alternatives, including your goals, constraints, variables, constants. You need to understand the outputs that result for each outcome. So your inputs are a series of data that are going to be used for generating outcomes. The data may provide by you or may be defined by the study type. And inputs can include variables, constants, or other supported input types. So a variable is a value that can change when generating outcomes. For example, for the 3-box massing study, which I'm going to show you in the software itself, you can define the box height and the box position. And then you can indicate which values are the variables for the study and which ones are the constants. A constant value is a value that is going to be fixed and does not change. And it's going to remain the same for all the outcomes. These values may be programmed as part of the Dynamo graph, so you can not change them. As an alternative, you can specify a constant value when creating a study. The same value is used for all outcomes in the study. When you're using the optimized method, you can use a goal, and then you can set a goal as an objective that you want to design to achieve, okay? So either you can maximize or minimize your floor area, or you can maximize or minimize your surface area. So that is another option that you can use when you are generating, using generative design. When we talk about constraints, you can constrain, as we're going to show in the box exercise, you can constrain the height of one of the boxes. You can constrain the floor area. You can constrain the maximum surface. Then you can define in the generation settings, you can change the settings, and then you will have multiple outputs. So let's go into the software itself so you can see it in Revit itself. So here I have a basic empty project. First of all, the generative design tool, you can find it in the Manage tab. Here where it says generative design. So first of all, you can come here and choose to create a study. So let's do that. And it opens up this create study dialog box, as I showed you in one of my first slides. You can have the option to see this as a list only or as a graph. So I'm going to use, and these are scripts that are provided by Autodesk with the software itself. Um, and they're just examples. You can open them up in Dynamo Player and continue editing them or creating different versions for that. As I mentioned before, for that you need to have somebody that is has some knowledge for programming. It's just C basic. So I don't have that knowledge, but I find the tool very easy to use. So I'm going to use this 3-box massing. So first of all, in the method, as I mentioned before, in the method, you can choose if you want to optimize space evenly, randomize, or like this. So I'm going to choose to optimize. My first box is going to be 160 feet. The box 2 height is going to be variable between 20 and 200 feet. I can define the distance, the position of box X. That distance is defined by the center of the box related to the center of the first box. Okay. And as you can see, you have very comfy sliders. And then box 3 is variable. So as I said, you need to have some constants, you need to have some variables. Right now, my goals, I want to maximize floor area and I want to minimize surface area. I can set my constraints. So I'm going to set my floor area to 60,000. And I'm going to, my constraint for the surface is going to be 80,000. And I'm going to click here on generate. And let me show you what Revit does. And for me, this is important if you had never seen generative design, because notice how fast it starts generating options for you. We are in option 3 out of 10, and it keeps giving me different solutions. So from my point of view, it's something like design options, but on steroids. And I can, once it's done, I can select each one of the options and check my metrics. Right, and then with these arrows or by picking any of the options that I have here on my screen, I can choose any of the options. I can investigate the options and what they're doing, and then I can create Revit elements. Now notice that it starts adding studies here. I had cleaned up this dialog box before coming to this webinar, but you can go on and keep studies like this, and they will stay in the Explore Outcomes dialog box, and you will be able to check them out at a later date. Okay, that is the first demo that I wanted to do for you. The other demo that I had prepared was thinking of this breakfast room area, and I want to see what my options are for laying out the seating. Okay, so again, I'm going to go and create a study. Yeah, it's just give me a second. I need to come here and make sure that let me close this model. There we go. So for these guys, I am going to use the stepped grid object placement, which is, I mean, I have done into experiments with the grid object placement, and I like this one better. For this room, it is going to be more attractive solution from my point of view. So there is a couple of steps, right? So I have the distance between objects. Through the x coordinate, through the y coordinate, the distance, maximum, minimum distance from objects to a wall. Then I can go and select a family instance, which I'm going to do, and I'm going to select this table here. And I'm going to select the room to populate, which is going to be this room. And I want to maximize my number of objects. I'm going to minimize the overlap. I'm going to minimize the object area outside the room, and I'm going to maximize the object area inside the room. I could have another set of constraints, but again, I just want to show you real quick how this runs and what your results are. And there it is starting to generate my layout options on how I could place all my seating in that breakfast area in that location. And now it's done. And again, I can check my outputs. I can investigate my variables, which are the distance between objects from the x coordinate and from the y coordinate, and the minimum distance from the wall. So before laying out objects, I can check solutions, right? Which looks the most convenient for that specific space, something like this one. Right, so here I have 14 objects. Here, for example, I have 15 objects. They're a little bit more crowded. I have a door coming in from this direction. But as you can see, it starts being very interesting in the design, in the discussion of how I want to lay out the space. Okay, so with this, let me bring you back to my PowerPoint. I don't know where my PowerPoint went to. Here it is. So questions. It's a broad subject. I mean, it leaves a whole room to play with. So it's an opener. Yeah, go ahead.
Sorry. Thank you, Sandra. Yes, we have one question here. First one is this type of analysis tool commonly used for fire sprinkler placement within a building?
It can be used. It can be used. As I said, this is an eye opener for you. Imagination is from this point on, the use of the tool is up for grabs. I mean, I would think, I don't know for sprinklers. I know fire design people, there are some specifics, but I mean, those can be your variables. You need to know the range of how much those sprinklers are spraying so that they cover one another. They don't leave any areas unprotected. So those can be your variables. So I would say very much so. I see the possibilities.
Perfect, thank you. The second question we have is, how is this different from other types of generative design?
Well, The generative design in Revit basically enables users to interact with generative workflows directly in the Revit context. So as you can see, you can select Revit elements, you can define goals, you can run a study, and then create elements back in Revit. I mean, I didn't show you that part, but you can create the elements back in Revit once you have made your design decision.
Perfect. The next question is it possible to create status for entire rooms that contains furniture families inside? I'm thinking about an office space where we want to arrange offices and conference rooms.
Yeah, yeah, that is exactly what it's used for. I mean,
Perfect.
that is an example, and that is why I wanted to show the example of the restaurant, because a work cubicle or table at a restaurant was meant to do.
Okay, perfect example. Our next question is who can use it?
Anybody. sorry, sorry. My bad. Basically, generative design is set for all the users with an AEC collection subscription. When you from 2021, it is baked into Revit with the subscription and the AC collection.
Perfect. And we have another question related to the AC collection. Can I access generative design features if I don't subscribe to the AC collection?
Well, basically, the answer to that is anyone with a Revit license. You can build generative design workflows for Revit just with the Revit license. The only downfall is that if you want to create and explore your workflows directly in Revit, you will need to have an AEC collection subscription.
Okay. And with that, I would like to remind everyone that if you want to learn any of these topics in detail, you can take a custom training with Sandra. And we have our class schedule in the right hand, on the right hand, I believe. You can check our class schedule and just inquire any quote from us and we'll get you going. This is our contact phones based on region and also my number there in case you have any questions. Um, we'll have another question. I think it's a good one. Maybe not everybody knows. It's what is an AEC collection?
The AEC collection is the Architecture, Engineering, and Construction collection. Um, Basically, it's a bundle of softwares that you can get by subscription that contains Revit, AutoCAD, 3D Max, gives you access to Forma, gives you an access to Autodesk Docs, which is also an awesome offering. Or Forma is also an awesome offering. I mean, you have a bundle of products that are very cost worthy from my point of view. Right? I do believe that every office nowadays would need at least a license of Revit and a license of AutoCAD. Buying those two licenses separate is going to be so much more expensive than getting the AEC collection, and you get like the world, everything that you need for architecture, engineering, or construction industry with that collection. That is the AEC collection.
Okay. And also, yeah, I wanted to remind you about our LinkedIn page. Yeah, I think you have the link also on the right hand. If you follow us, you can check all of our news and all of the upcoming events that we'll be planning with a link to them, of course. And as usual, I always recommend you to register even if you cannot make it, so you can receive the on demand recording. So yeah, I don't know if I'm forgetting anything, Sandra, but yeah, with that, I would like to thank everyone and thank you for this webinar.
Thank you for coming, guys.
Bye bye.
Bye.